So let's go over some background information for our task, A Home Away from Home. So first, I want to discuss what a planetary system is because our task is based in outer space. So a planetary system includes planets as well as asteroids, meteors, comets that are orbiting around a star or a star system. A very famous example of a planetary system is our very own solar system. And next, let's talk about luminosity. This is a measure of a star's intrinsic brightness. It's defined as the amount of energy that a star emits in a fixed amount of time. Next, let's talk about the habitable zone. This is a distance at which liquid water could exist on the surface of a star's orbiting planet, which is very important when we're looking for planets that may be able to sustain life. And this distance usually depends on the luminosity of the star that you're looking at. And briefly, I want to discuss period, diameter, and radius of a planet. A period is how long a planet takes to complete one orbit around the star. A diameter is a straight line passing from side to side through the center of a planet. If you look at this diagram right here, this dark orange line would be considered the diameter. Radius is the straight line from the center to the circumference of a planet. So on this diagram, the radius would be this light orange or yellow line going from the center to the edge. Now I want to take some time to discuss Kepler's third law of motion. This equation relates the planet's orbital distance to its period. This equation is useful if you have the period of a planet and you want to find out the distance of its orbit away from the star, or if you have its distance from its star and you want to find out its period. So the equation is p squared is equal to kd cubed, where p is the period of the planet's orbit around the star, the k is Kepler's constant, and d is the distance of the planet from the star. There is also this equation that you can use to figure out the Kepler's constant. This will be unique to each star that you look at. And this equation is 4 pi squared divided by the gravitational constant, which will be given in the task, and the mass of your specific star. So let's work through a few examples. So the first example, we're going to calculate how far the Earth is from the Sun. So first, we're going to figure out the Kepler's constant of the Sun. Here we just have the equation, k is equal to 4 pi squared over gravitational constant times mass of the Sun. So we've just plugged in the gravitational constant, which is 6.7 times 10 to the negative 11, and the mass of the Sun, which is 2 times 10 to the 30. And you get the Kepler's constant of the Sun, which is 2.95 times 10 to the negative 19. So we know the Earth's period is 1 year. However, to use Kepler's equation, we're going to have to convert this to seconds. So 365 days converted to seconds is 31,536,000 seconds. Now we can plug this value in for the period, plug our Kepler's constant in for k, solve for d, and you'll get the distance, which is 1.5 times 10 to the 11 meters. Or you could say it's 150 million kilometers, which is the distance of the Earth from the Sun. Next, quickly, we'll go over the distance of Jupiter from the Sun. So we don't have to calculate the Kepler's constant again because we're still looking at the Sun, so Kepler's constant remains the same. However, Jupiter's period is different from that of the Earth's. Jupiter's period is 12 years. Now first, we're going to convert that to seconds. So 12 years in seconds is 378,432,000 seconds. We're going to plug this value into the period and use our Kepler's constant for k, solve for d, and you get 7.86 times 10 to the 11 meters. This is also 786 million kilometers, which is the distance of Jupiter from the Sun. Lastly, I want to see some other terms that you're going to come across in the task. So a gas giant is a giant planet composed mainly of gas. They won't have a hard surface that you can land or walk on. An example of this is Jupiter. A terrestrial planet is made up of rocks or metals with a hard surface, and an example of this is our very own Earth. Helium-3 and uranium-235 can be used for fuel. Helium-3 can be used in nuclear fusion reactors, and uranium-235 can be used in nuclear fission. That should be all. Good luck in the task.